Welcome back. So in this video we're going to talk about how to use tables and rates of change to solve word problems, both linear and nonlinear, just like the ones you'll see in your Math Excel. So here goes. When a scuba diver goes underwater, the weight of the water puts pressure on, on the diver. The table shows how the water pressure on the diver increases as the diver's depth increases. So, part A, what is the rate of change for this linear function? Notice it's already telling us it's linear, so we're not looking for that. We're just looking for the rate of change. We already know it's linear. And what does this rate of change represent for the situation? So since we already know it is linear, I can pick any 2 points. So I'm just going to do 13.2 and 8.8 with the 30 and the 20. So easy, 30 minus 20 is 10, and 13.2 minus 8.8 is 4.4. And then to find my rate of change, I'm going to do 4.4 divided by 10. Another way I could have set this up just like we've been doing with slope, which is writing it out 13.2 minus 8.8. Actually, I'm going to give myself a little bit more room here. Minus 8.8 over 30 minus 20. So again, rate of change is just slope. So we ended up with 4.4 over 10. And what this means is the diver, so the pressure increases, and I can't spell tonight evidently, or today. The pressure increases 4.4 pounds, should be an L, per square inch for every 10 feet in depth. So for every time the diver goes 10 feet, another 4.4 pounds per square inch of pressure is added to the diver. That's what that represents. Now use the rate of change to predict the water pressure on a diver at a depth of 60 feet and then again at a depth of 100 feet. So right now we're at 40. So then we'd go to 50, then 60, 70, I don't know why I put, oh, because I started to think 80 in my head. 70, 80, 90, 100. So from here, 17.6, I'm going to add 4.4. So at 50 feet, we're at 22. Add another 4.4. At 60 feet, we are at 26.4. So 60 feet, we're at 26.4 pounds per square inch. So then I'm going to add another 4.4 and we get 30.8. Add another 4.4 and we get 35.2. Do it again and we get 39.6, and we do it one last time and we get 44. So at 100 feet, then there is 44 pounds per square inch of pressure on the diver. But I've used the table. I used my rate of change to continue the table and figure out further predictions on how, in this case, pressure, or what my y value is based on x values. All right, so next word problem. Suppose there are 20 rabbits on an island and that the rabbit population can triple every 6 months. So we're going to make a table of values to find how many rabbits there would be after 2 years. And if I remember right, I need to start my table clear up here. No, you don't move. All right, clear up here. So we have x, y. X is months, and y is number of rabbits. All right, so every 6 months. So we're going to start with 0, 0, because well, I guess you kind of have to have rabbits. There are 20 rabbits. That's wrong. 0, 20 is where we are. So every 6 months, so after 6 months, we triple. So we're going to take 20 times 3, and we get 60. And then we're wanting to get to 2 years. So 6 months, then we're at 12 months. So that's 1 year. So then 60 times 3, and we get 180. And then another 6 months, we're at 18 months now. Take 180 times 3, and we end up with 540. And then we do another 6 months, so we're at 24. So that's 2 years. And so we're going to do 540 times 3, which is 1620. So make a table of values to find how many rabbits there would be after 2 years. And the answer is 1,620 rabbits after 2 years. Now, does this relationship represent a nonlinear function, and explain? Well, when we look at this, the difference between 60 and 20 is 40, but the difference between 180 and 60 is 120. And so that tells us that this is a nonlinear. So yes, nonlinear, because it doesn't have a constant rate of change. Oops. Doesn't have constant rate of change. Okay. Now, using the table, when would you expect the rabbit population to reach million? 1 million. So, I'm going to take that 1620 and I'm going to take it times 3 again, because again, we triple that. So now we're at 4,860, all right, and that's 24 plus 6, which is 30 months. And then at 36 months, and I'm pretty sure I need to start writing smaller, we're going to do 4,860 times 3. So that's 14,580. And then we're going to take that times 3, and we end up with 43,740. And we're going to take that times 3, and we end up with 131,220. Oops. 131,000. No, go back. 131,220. I'm going to take that times 3. We'll fill in the x's. I'm just doing all this times 3 right now, and we get 393,660. Take that times 3. And now 1,180,980. So now we are at 1,180,980. And so this one was 36. So another 6 months gets us to 42 months, plus another 6 months and we are at 48 months, plus another 6, and we are at 54, plus another 6, and it takes 60 months, which is 5 years, and really it takes about less than 5 years, but it is approximately 5 years is when we would reach the 1 million rabbit mark. And that's how using a table to estimate nonlinear function or values. So until next time, guys.